Good evening, everyone, and welcome to Environmental Coffee House. I am your host, Sandy Schoelles, and this is my host with the most, Jennifer Hynes. I'd like to say hello to everyone first out there. We are going to have a good show. We have a busy show. Everybody, let's just sing Kumbaya, and there's a lot of love. Okay, Jen, so what's going on?
Right. So tonight we're going deep into virus land. We're going to actually have a little bit of a history lesson, and we're going to start to understand how the melting permafrost, or the thawing permafrost rather, is affecting and making viruses come out. So the first one up is from Scientific American. This is actually back from 2016. As we look back, what happened 7 years ago, as the earth warms, the diseases that may lie within the permafrost become a bigger worry. So that was 7 years ago. Then we're going to take a look at 2020 from Nature World News. Melting of Arctic permafrost brings long dead viruses back. So you can see a trend here. We're going to drop over to phys.org. Russian scientists probe prehistoric viruses dug from the permafrost. That's from 2021. So we're kind of moving up the line here.
Yep.
And this actually is pretty interesting. It's got some mammoths in it. Then we're going over to Nature World News. Prehistoric animal viruses from the permafrost caught interest of Russian scientists. So that's from 2021. We're going to see what happened then. And we're going to take a quick look, a little geography lesson here. We're going to take a quick look at the Lena River, and including the Lena River Delta, which is a very, very rich region of permafrost and all sorts of biomatter. Then we're going to run over to State of the Planet, Columbia Climate School. What lies beneath the melting glaciers and thawing permafrost? So this from 2022, almost up to current day. Then we have an article from CNN, and it's actually
Mainstream.
from today or the day before yesterday. So this
Mm-hmm.
is actually right now. Scientists have revived a zombie virus that
Yeah.
spent 48,500 years frozen in the permafrost. So
I
good
have a caveat on that one a little bit.
to you.
Hmm. I do.
Yeah.
Well, I might as well tell you. As I was going through this, Jen, it's like everyone and their brother picked up on the story about 3 months ago about when the research started coming out,
Hmm.
and CNN, all of a sudden, they're like 3 months late. But now, once they picked up on it, there were 100 stories on this. There were all
Mm.
kinds of things out there on this, and I thought, you know what? Let's just go through the history. And then you and I went back and forth, so we started to decide to go through the history of this because, again, even podcasters, they're all doing shows about it, but they're leaving innuendo, they're cherry picking, they're not really talking about the researchers, and we are.
Mhm.
So there
Mhm.
you go, we're talking about the researchers.
Yeah, and then we're going to finish up with Yale Environment 360, how tensions with Russia are jeopardizing key Arctic research.
Yeah, big
So
drag.
very interesting. So, fasten your seatbelts. It's going to be a scary ride with viruses coming out of the permafrost, all
Yeah.
kinds of them.
Yeah, we'll see how scary it is. So we're going to start. I hope I have the right one up. We were going to start with, yeah, Scientific American, right, Jen?
Hmm.
Did
Yeah,
you want to do this? We didn't
sure.
actually. Yeah, why don't you do this? Now, this was from 16, and it was
Hmm.
really good. I thought it was really good to have this one
Hmm.
as a start. I even went back farther to 2012, but I decided, oh, we're not going to be here all
Hmm.
night, right?
Yeah,
So,
that's right.
all right,
That's right.
let's go. Get
All
going.
right. So, Scientific American, this from 7 years ago. As the Earth
Yes.
warms, the diseases that may lie within the permafrost become a bigger worry. Scientists are witnessing the theoretical turning into reality, infectious microbes emerging from a deep freeze.
Hmm.
So, this past summer, anthrax killed a 12-year-old boy in a remote part of Siberia. You guys remember this, right? Remember when this happened? At
Yeah.
least 20 other people from also from the Yamal Peninsula were diagnosed with the potentially deadly disease after approximately 100 suspected cases were hospitalized. Additionally, more than 3,200 reindeer in the area died from the infection. The
You guys
likely
remember?
cause, thawing permafrost. I do remember.
Yeah.
I do remember. According to Russian officials, thawed permafrost permanently frozen layer of soil released previously immobile spores of Bacillus anthracis into nearby water and soil and then into the food supply. The outbreak was the region's first in 75 years.
Wow.
Researchers have predicted for years that one of the effects of global warming could be that whatever is frozen in permafrost, such as ancient bacteria, might be released as temperatures climb. This could include infectious agents humans might not be prepared for or have immunity to, scientists said. Now they are witnessing the theoretical turning into reality, infectious microorganisms emerging from a deep freeze. Although anthrax occurs naturally in all soil and outbreaks unrelated to permafrost can occur, extensive permafrost thaw could increase the number of people exposed to anthrax bacteria.
Mm.
In 2011, a paper published in Global Health Action, co authors Boris Rekvik and Marina Poltnaya wrote their predictions. As a consequence of permafrost melting, the vectors of deadly infections of the 18th and 19th centuries may come back, especially near the cemeteries where the victims of these infections were buried. Ooh.
Yeah.
And
Pretty heavy.
permafrost is indeed thawing at higher latitudes and greater depths than ever before. In various parts of Siberia, the active layer above the permafrost can thaw to a depth of 50 centimeters every summer. This summer, however, there was a heat wave in the region and temperatures hovered around 35 degrees Celsius, which was 25 degrees warmer than usual. The difference possibly expanded or deepened the thaw and mobilized microorganisms usually stuck rigid in the earth. Although scientists have yet to calculate uh, I lost my place. Although scientists have yet to calculate the final depth, they postulate that it is a number that has not yet been seen in almost a century. Permafrost thaw overall could become widespread with temperatures only slightly higher than those at present, according to a 2013 study in Science. Heat waves in higher latitudes are becoming more frequent as well. What thawing permafrost could unleash depends on the hardiness of infectious agents involved. A lot of microorganisms cannot survive in extreme cold, but some can withstand it for many years. Um, Anthraxis are special because they are spore-laden bacteria. So Jean-Michel Claverie,
Our guy.
our guy,
Our
the
guy
virus
tonight.
hunter, the virus hunter,
Yeah.
head of the Mediterranean Institute of Microbiology and professor at Aix-Marseille University in France. Spores are extremely resistant, and like seeds, they can survive longer than a century. Viruses also survive for lengthy periods. In 2014 and 15, Claverie and his colleagues Chantal Abergel published their findings on two still infection viruses from a chunk of 30,000-year-old Siberian
Permafrost.
permafrost.
Yep.
So, although this virus can affect amoeba, the discovery is an indication that that infect humans, such as smallpox and the Spanish flu, could potentially be preserved in the permafrost. Human viruses from even further back could also make a showing. For instance, the microorganisms living on and within the early humans who populated the Arctic could still be frozen in the soil. There are hints that the Neanderthals and the Denisovans could have settled in northern Siberia and were plagued by various viral diseases, some of which we know, like smallpox, and others that might have disappeared. The fact that there might be an infection continuity between us and ancient hominins is fascinating and might be worrying.
Might. Might.
Is, yes. Janet Jansen, who studies permafrost at the Pacific Northwest National Laboratory in Washington State, is not worried about ancient viruses. Several attempts to discover these infectious agents in corpses have been coming up empty, she notes. She does advocate, however, for further research to identify the wide range of permafrost dwelling microorganisms, some of which could pose health risks. To accomplish that goal, she and others are using modern molecular tools such as DNA sequencing and protein analysis to categorize the properties of unknown microorganisms, sometimes referred to as microbial dark
Dark
matter.
matter.
The
Yeesh.
likelihood and frequency of outbreaks, similar to the one in Siberia, will depend on the speed and trajectory of climate change. For instance, it is possible that another heat wave will expose the carcasses of animals infected by anthrax, Revich said. The situation on the Yamal Peninsula has shown that the risk of the spread of anthrax is already real, he adds. The effect in effect, infectious agents buried in the permafrost are unknowable and unpredictable in their timing and ferocity. Thus, researchers say that thawing permafrost is not our biggest worry when it comes to infectious diseases and global warming. The more immediate and certain threat to humans is the widening geographical range of modern infectious diseases and their carriers, such as mosquitoes, as the earth warms. We now have dengue in southern parts of Texas, says George C. Stewart McKee, professor of microbial pathogenesis and chair of the Department of the Veterinary Pathobiology at the University of Missouri. Malaria is seen at higher elevations and latitudes as temperatures climb, and the cholera agent Vibrio cholerae replicates better at higher temperatures. Unlike zombie microbes lurking in the permafrost, modern spreading diseases are more of a known quantity, and there are proved ways to curb them, mapping trends, eliminating mosquito breeding sites, and spraying insecticides. Of course, dramatically lowering fossil fuel emissions to combat climate change could tackle both threats: the resurgence of ancient and deadly pathogens and the widening ranges of infectious diseases in one shot.
So, folks, that was 2016 Scientific American. So, pretty
Yes.
mainstream. A lot of this is mainstream, a lot of it is ignored. Jennifer, I went back to look at how many shows we've done that had the words permafrost. We have
Really?
a whole playlist of Arctic and permafrost stuff. We
Really?
really do. Yeah,
Oh
we do.
my.
I have to make a playlist of it
Oh
because we
yeah.
do. When I was like, should I play something? Should I do something? Nah. All right. I'm going to move on now. We're not reading this one. It's just going to show you that in 2017, they moved up. Okay. So then it was the Atlantic, went from Scientific American to the Atlantic. Look at that artwork. That's why I picked it. It was kind of like, okay, a little dramatic.
Oh.
The mainstream media, completely dramatic. And they also called it the zombie disease of climate change. What lurks in the Arctic's thawing permafrost? And I'm not trying to sound like, woo, scary and all that, because really, basically, the bottom line is we don't know if anything's going to even ever go to a human. But we're going to get there. I'm jumping ahead of myself. So the only thing I wanted to show you was the pictures on this one because it was pretty good. And of course, everything will be in the show notes. In all of the places, they talk about the if there are microbes infectious to humans or human ancestors, we're going to get them. And remember, this is all before Corona panic.
Wow.
What the hell he called it? Corona. So it's all before SARS-CoV-2, all of it. And on purpose. Okay, that's why we're doing a history, because this guy, Dmitry Ivanovsky, this is history. And I made a video for us at intermission, and there is some history. So we're gonna do a little history. That's why we don't need to read this whole one. Just wanted to show you the pictures. In 17, again, Claverie, and they were talking about him. From France, and he was working with the Russian team, and we will move on. I just want to get to the wow. At once, you're going to excavate 16 millions of tons of permafrost that has not been moved in a million years, because of course of all the things they're talking about, making, industrializing the Arctic. So the artwork was pretty good on this one. Look at that. There's the little mushrooms. I like the artwork, but I don't want to read. It's a very long one. And this is, I thought this was pretty nice. So we're going to move on. We're going to move on to something that's not as mainstream. This is Nature World News. And I picked this, and Jennifer liked it because it's a little off the beaten path, but they had good lengths. And Jen, do you want me to do this one, or would you like to take this one?
Either way,
All
as
right.
you wish.
All right. It's short, but it tells a story. The melting of Arctic permafrost brings long dead viruses back. So you're getting that this is from 2020 now. We're jumping up in all the different media, right? And I mean, it's an ongoing story. Most scientists agree that climate change in the Arctic has caused the melting at a rapid rate. They're using the melting Arctic also brought about new occurrence. It reemerged new viruses and bacteria that were long gone. Uh, wait a second, Jennifer. I'm sorry. Okay, so during discovery of the 1918 Spanish flu virus in the 1990s, the melting Arctic article from Permafrost in Alaska thawed, revealing an Inuit woman who was believed to be a victim of the Spanish flu in 1918. So her body was able to preserve the virus as body fat kept her lungs insulated against warmer temperatures. The discovery of the virus allowed scientists to study the its genetic blueprint and give a picture of why it became a pandemic. Remember, this is 2020, I think, before anything else was being published about SARS. So it took 10 years to determine the Spanish flu's genetic makeup. Last year, the investigation team published their study and identified the deadly strain of the 1918 gene and revealed that the pandemics of 57, 68, 2009 emerged from the 18 strain. Interestingly, the 18 virus was also genetically closed to a bird virus that still exists. Oh, closed. Okay. To a bird virus that still exists today. Research also concluded that a universal flu vaccine against different strains could be developed from the 1918 strain, thus averting the need for annual vaccination. Now, we don't know this. This is 2020. This is, again, not a very scientific online source. But it is something that people will read, that not our savvy audience maybe would have picked, but people will read these things. And they nailed it. they hit it. They said the climate change in the Arctic has led to the rising temperatures that are rapidly melting that permafrost. We know that the permafrost releases huge sums of methane, and Jennifer and I have done that before. You know those shows. A potent heat trapping gas. There is, however, a good side to the circumstance. The melting of the Arctic also bears the origin of long buried diseases such as scarlet fever and coronavirus, giving researchers more of an opportunity to study previous outbreaks and provide a better perspective in coping with new ones. Scientists admit there is a tiny danger that dormant diseases from underground may be resurrected. The carcass of the 75-year-old reindeer infected with anthrax is believed to be the cause of the anthrax breakout in 2016. So I'm going to move up a little, and I want to go down to the Arctic soil here. It's also the host of the bacteriophage, or viruses that'll kill bacteria. These viruses are important as it has the potential to curb antibiotic resistant bacteria. It's like a circle of life. Viruses are all over. We have viruses all the time in us. Most of them are so innocuous, but that's life. But viruses need a host. Bacteria does not. So, risks of melting Arctic permafrost. There are also dangers that, and everybody's reiterating this, that these long buried diseases may come to life. By the end of the century, the Arctic permafrost, which used to be as large as Russia, may shrink to the size of Alaska due to climate change. This occurrence is alarming because the dormant microbes trapped in the permafrost activates when the grounds melt, consuming decomposed plants and releasing gases that add to global warming. Janet Jansen, chief scientist for biology in the Pacific Northwest National Laboratories Division, the Biological Sciences Division, she said, so the melting of the permafrost could change the world. It's going to change the world. And it could unearth new life-saving discoveries also. We don't know, right? We don't know. So that led us then up to, again, 2021. Jen, if you want to take this one, see, guys, how we're taking you on a bit of a trip through this, and we do have an intermission video also where we're going to introduce you to our virus hunter. So take it away, Jen.
Sure, guys. So this is from phys.org. We're up to 2021, as Sandy said. Russian scientists probe prehistoric viruses dug from the permafrost. Russian state laboratory Vector on Tuesday announced it was launching research into prehistoric viruses by analyzing the remains of animals recovered from melted permafrost. The Siberia-based lab said in a statement that the aim of the project was to identify paleoviruses and conduct advanced research into virus evolution. The research, in collaboration with the University of Yakutsk, began with analysis of tissues extracted from prehistoric horse, which was believed to be at least 4,500 years old. Vector said the remains were discovered in 2009 in Yakutia, a vast Siberian region where remains of Paleolithic animals, including mammoths, are regularly discovered. Researchers said that they would probe too the remains of mammoths, elk, dogs, partridges, rodents, hares, and other prehistoric animals. Maxim Chapasov, head of the Mammoth Museum Laboratory at Yakutsk University, said in a press release that the recovered animals had already been subject to bacterial studies. But he added, we are conducting studies on paleoviruses for the first time. The former Center for Development of Biological Weapons in Soviet times, the Vector Laboratory in Siberia's Novosibirsk region is one of only 2 facilities in the world to store the smallpox virus. vector has still developed a vaccine against the coronavirus, Epivac Corona, which was licensed in October in Russia and is scheduled to begin mass production later this month. Scientists say that the Arctic warming is warming twice as fast as the global average. That was then, now 4, right? Endangering local wildlife as well as releasing carbon stored in the melting permafrost. So there you
Mm.
go. So all about viruses in
Fizzorg.
2021, 2 years
Yep.
ago.
Yep. And then, we're moving fast, but we there's nothing to dilly-dally at. Everything's right here, and we're doing the history. So this is another one from Nature World News, and this again they're talking about the examining prehistoric viruses from Siberian permafrost in the animal Doug. I wonder who wrote this. A lab in Russia's Siberia state is beginning to study about prehistoric viruses conserved in the remnants of animals discovered in the permafrost. So this was, again, led by biotechnology, the University of Yakutsk, and the Vector State Research Center of Virology. The research will begin by examining the tissues from that prehistoric horse from 4,500 years ago. So this is a picture of Yakutia. I am just enthralled with that whole area. I mean, it is someplace that I would love to visit. I always wanted to do, Jennifer, the Trans-Siberian Railway, and I hope that
Yeah.
we get to do that again. I hope all of the mess goes away, but that's not what we're here to talk about. So they also were talking about other prehistoric animals like we read before. And this one, the 28,800-year-old Maliakavoski woolly mammoth and more. Some of the remnants are above 50,000 years old. All of them discovered because of the thawing, because of the loosening permafrost. Now, one may marvel if this type
Mm,
of
mm,
study is
mm.
opening a Pandora's box. And Jennifer, Pandora's box is all over the internet in videos. Everything I did was like, okay, Pandora's box, Pandora's box, Pandora up in the Arctic. It's the biggest issue nobody talks about, although Kyle Klinsky did it and a couple of others. They'll get 50,000 views and we won't. But we're doing a good show because we're not cherry picking. We're giving you some real good stuff here. So, and I'm not sounding like I'm not being a poop head. Anyway, so the Pandora's box in some way to ancient viruses, but this isn't the first time viruses of such have been researched. In fact, with the Arctic warming at 2 times, now when this was written, it was 2 times, right, Jennifer? Now it's 4
Mhm,
times. So in
mhm.
what, 2 years, they've discovered that the Arctic is melting 4 times the rate.
That's right. That's
Yeah,
right.
in
Just wait 2 years from now and
2
see
year,
what
yeah,
happens.
right, exactly.
Yeah.
So, we're gonna go down to Olyeska Okpovka, and she is a vector researcher. She said that the group of Vector Virology Center, they're eager to search about paleoviruses that would enable them to begin development of paleovirology in Russia and conduct spearheading research in virus evolution, which is cool. It's like way cool and to me.
Yeah.
Research on these animals, there's only been a little study on the soft tissues, but the vector team is searching to oversee the infections in animals by separating the total nucleic acids and sequencing the genomes, which is so fascinating, to generate more information on biodiversity and the microorganisms in ancient animals. Ok- Oklapovka, I think. No, I had it perfect earlier. Okpov, Okpovka disclosed that it should conserve nucleic acids. We are expected to be able to generate data and their creation and ascertain how it altered. That's wild. We can deduce the epidemiological capacity of currently existing infectious agents. It is located in the Novosibirsk. Oh, you said it right. Novosibirsk. Sorry, guys. I did try, Jennifer. I tried with this. But during the Soviet times, it used to be the Center for Advancement of Biological Weapons. No good. We don't like that. It's one of two locations across the globe that presently stocks the smallpox virus. So that's basically, we've already heard about that. Um, they go down and they talk about the viruses that can come out of prehistoric animal research. Cases of arising deadly viral infections have considerably influenced human health, despite unusual development on the part of biomedical knowledge. The decent examples are resurfacing outbreaks of chikungunya, fever, and dengue in tropical and subtropical locations, the latest epidemic of Zika in the Caribbean, and the best example, recurring outbreaks of dengue and chikungunya in those tropicals. And then, of course, they talk about MERS, SARS, and influenza A, all the regular, all the usual suspects, right?
Mm-hmm.
Mm-hmm.
Zika also.
Yeah, it was big time stuff going on, and it still is being researched. Now, Jen, I don't know if we should do the Columbia article first or if we should take the break and play my video. Is everybody ready for the break?
Yes.
You ready for the break? All right. We're going to take a break. I made a video that we're going to watch, and our virus hunter is in it, right? And you're going to get a little history from what I put together. You'll learn about bacteria and viruses. All right? So here we go. Enjoy the show.
general the lab is doing, but I'm going to talk about viruses in the permafrost. And most of Siberia is actually permafrost, and most of it is very ancient. The bad thing is that actually the permafrost is melting, and is actually melting more in the region of interest, which are basically, we are going to talk about this part of the region right here, which is actually basically warming up 3 times faster than the rest of the planet. So there is some kind of urgency to know what might be in there. It's some kind of methane explosion, but nobody is there to listen to it, so we don't know where it's actually coming from. And in fact, active layer melting, but sometime when the summer is higher than warmer than usual, the active layer is thawing on a larger depth. And then, this one was 70-year-old layer that never thawed before, and then because of the very hot summer in 2016, this layer was melting and released anthrax spores. This is where we come in, things which are in fact much farther back in time. Okay, rescue a plant, we should be able to rescue a virus, and so this is what we've done. So now I'm talking about where we work with our ocean collaborators in Turkey. We are in fact based on the very famous Zimov stations, if people knows about it. Okay, this is another place where you are going to spend your winter vacations. Summer is fine. Okay, and we look for cell lysis, and when we have cell lysis, we isolate the agent and characterize it very thoroughly. Infectious cycle, genomics, transcriptomics, and proteomics. Okay, so we do everything that we can with the virus. And doing this, on one of the samples that was given to us by the Gilisinski lab, we isolated 2 new viruses. Okay, when I'm saying isolating, we have those viruses, they are alive, they are in the lab, we can produce kilograms of it. Okay, so this is not just looking at DNA. Those are very big DNA virus genome. It's not the part of the talk here that are called giant viruses, but of a single sample, we're able to revive 2 new viruses. At the time, those viruses were not known to the world. They were the first member of their new family. Okay, so that was easy to publish in the sense that we were not accused of contamination because nobody had seen those viruses before. We use different sample sites, we use different sample types, and we use different investigation methods. Okay. Thanks to some of our collaborators in St. Petersburg, we got access to the Yana rhino horn site, which is on the Yana River mouth, okay, which is probably the first example that, in fact, human coexisted with mammoth and probably killed them for food, actually. And so this is a place when, every winter there is thousands of pieces of mammoths that definitely go out of the ground. And so it's full of material that you can get frozen and that you can actually study. In St. Petersburg, we got access to a piece of mammoth hair or skin, if you want, that was maintained frozen for 40,000 years. We work with the Alfred Wegener Institute, which has access to Yakutia, which is a very difficult thing to do. And we have a lot of corals that I got in Potsdam, okay? And we did metagenomic sequencing, which is we take the whole sample, we extract the DNA, and we sequence the whole thing to see what is there. Most of the viruses we got are the ones we knew about. Most of them are the giant viruses that infect protozoan, amoeba. But there is a lot of other viruses in lower quantity. Again, the numbers are very big. We have about 1,000 million base pair of viral DNA there, okay? And again, which is the exposure. This is a small forest, a lot of shrubs. It's very difficult to work in there because of the ice melting. You don't know where you put your feet. It's very easy to break a leg, so it's not as easy as it looks like. So this is on the cliff side. Okay, you have those ice wedges, which are the proof that what is here is been frozen for a very long time. Okay, this is permafrost. This is like concrete. Okay, Yakutsk, a whole city of 3,000 people, is actually built on this. Okay, so this is, but once it's stored, this is what you have here. So this is real concrete. What about the hazard? Well, it depends on the presence, viability, and resilience of known and unknown viruses, because we don't know who killed Neanderthal either. okay? Because we are always thinking about, old, present viruses, a virus that we believe we could recognize. Well, I discovered in the last 15 years 5 new families of viruses that were not even known to exist. Okay, so I don't think that virology is extinct. Okay, there are a lot of new viruses that we can discover that might be dangerous to human, animal, or plants. But if those DNA viruses are able to survive, I don't see why other viruses, which are, by the way, also cytoplasmic viruses, will not be able to survive that long. Okay. The only problem with that, first, we don't have the equipment for that, and not much people have that. And the last thing is that I will not tell you how we do, but it is virtually impossible to legally export infectious sample from Russia, and even more from Yakutia. So this is really something that has to be put in the context of international relationships and things like that, and even internal relationship between Yakutia and Russia, because even Russian scientists have difficulty to get to get things from Yakutia. Thank you very much.
So he was not always the virus hunter. He's a microbiologist. He actually did ocean biology, and his lab is pretty cool. I'm going to have a lot of links for him in the videos I've watched, and he said it's, at least in 2018, everything was so, you had to dot your I and cross a T. I mean, and I watched a few of his videos, and he talked about how they were so lucky to get those samples from the Russian lab, and how well they all worked together. In that, it's invaluable, because the Russian scientists are amazing. And he was talking about, I'm gonna show you just really quick. He was talking about David Gilchinsky, and David had a lab in. He studied microorganisms in permafrost and astrobiology. He died in 2012, which is a huge loss from heart complications. He was only 65, and he was in Pushchino, Russia, and he did a lot, and so it was a big loss to lose him in 2012. And that was one of the thanks that the good doctor.
Mm-hmm.
Yep.
Yeah.
So, Jen, and everybody in the chat, I think it's time to go on to one of the pièces de résistance, and Jennifer's going to read it. This was from Colombia. Really, I liked it, so take it away.
Right. So this is from, as Sandy said, the Columbia Climate School State of the Planet. And this is out in 2022, September, so just a few months old. What lies beneath the melting glaciers and the thawing permafrost? Across the planet, ice is rapidly disappearing. From mountaintops, the poles, the seas, and the tundra. As the ice melts, it's exposing new surfaces, new opportunities, and new threats, including valuable mineral deposits, archaeological relics, novel viruses, and more. Melting glaciers and sea ice, the Arctic is warming 4 times faster, that's a bit better, than the rest of the planet. And this means that glaciers, which sit on land, and sea ice, which floats in the ocean surface, are rapidly melting. 2/3 of the Arctic sea ice has disappeared since 1958, when it was first measured. Between 2000 and 20 19, the world's glaciers lost 267 billion
That
tons of
is,
ice
oh my God.
each year. Each year. Each
I
year.
know.
And it's exponentiating. Himalayan glaciers are on a trajectory to lose one third of their ice by 2100, and alpine glaciers are projected to lose half of theirs. Quote, I can tell you from our research that the bedrock underneath the ice will become exposed at a much higher speed than we think, said Georg Schaefer, a climate geochemist at Columbia Climate School's Lamont Doherty Earth Observatory, who is researching the Greenland ice sheet. Quote, all of the predictions are way too conservative in terms of change. The change will be much faster. That's true globally. But Greenland might be one of the areas where these predictions of ice change are way, 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 that's three ways, too conservative.
Three way.
He said three ways, way, way, way,
Way, way,
too
way.
conservative. He's like trying to make points, way, way, way too conservative because of a variety of climate factors. Because of the global warming human activity has already caused, Greenland's melting will cause sea levels to rise 10.6 inches, according to a new study. 10.6 inches, way, way, way too conservative, I think. This amount of melting is already locked in, said the study's authors. They add that 10.6 inches is a low estimate. If emissions continue and Greenland's record breaking melting of 2012 becomes the norm, we could be facing 30 inches or more of sea level rise. The loss of ice from West and East Antarctica ice sheets and from other glaciers would add to this. The resulting potential sea level rise would spell disaster for 680 million people who live in low lying coastal areas around the world, and a number expected to be top 1 billion. The number's expected to top 1 billion by 2050. What lies under the melting ice? Fossil fuels and precious metals. Until recently, most exploitation of Arctic's oil and gas resources were on land. But summer ice cover in the Arctic could disappear by as early as 2035, making the region more accessible to ships and providing new opportunities for fossil fuel extraction and mining. The United States Geological Survey has estimated that about 30% of the world's undiscovered gas and 13% of the world's undiscovered oil may be found north of the Arctic Circle, mostly offshore in the ocean.
Jen,
Yes?
when I read this, I literally started crying.
Oh, did you?
Yes, because of all of the extraction that they want to do. And I'm
I mean,
sorry to interrupt, but it just
it's
started
okay.
I was emoting, feeling those things again while you were reading it. I
Yes.
just wanted to tell you.
It's sad. Everything's really sad. In addition to these fossil fuels, the U.S. Congressional Research Service estimated that the Arctic contains $1 trillion worth of precious metals and minerals. Well, you just better hang that up.
Whoopee.
They're just going to be going for that. Greenland has deposits of coal, copper, gold, nickel, cobalt, rare earth minerals, and zinc. As the melting ice uncovers land that has been inaccessible for thousands of years, prospectors are moving in. Schaefer's research involves sampling underneath Greenland's ice using isotope tools to figure out when the area was last ice free in order to identify the most vulnerable segments of Greenland's ice sheet. He is often questioned by mineral consortiums. Quote, they just want to know what's underneath the ice sheet. Send us your
Right.
rocks. We need to know what
Ugh.
minerals are in there. And when is it gone? Or what does it take to melt it? End quote. They just want to get into these mineral deposits, he said. Valuable metals are also found in the deep seabed in the Arctic and elsewhere. Potato like nodules on the Arctic ocean floor contain copper, nickel, and rare earths, such as scandium, used in the aerospace industry. Norway is exploring deep sea mining of the ocean floor to exploit deposits of copper, zinc, cobalt, gold, and silver. The International Seabed Authority has already approved 30 contracts for seabed exploration. Mining the ocean floor could cause serious harm to marine ecosystems, including the plankton that are the basis of the food chain. And while deep sea mining companies claim their environmental impacts are less than those of land mining, much of the deep sea and its ecosystems remain largely unexplored. Several companies and environmental groups are calling for a global moratorium on deep seabed mining until its environmental impacts are better understood. However, avoiding the worst impacts of climate change means transitioning from fossil fuels to renewable energy, which requires large quantities of minerals. As much as 3 billion tons of metals, including lithium, nickel, manganese, cobalt, copper, silicon, silver, zinc, iron ore, and aluminum, may be needed for technologies such as batteries for electric vehicles, wind turbines, solar panels, and other clean energy technologies, so called clean. The World Bank estimates that the production of minerals could increase by nearly 500% by 2050 to meet the growing demand for renewable energy technologies. And can I say, Sandy, WASF? One ecologically sound alternative to mining the exposed land or deep seabed would be to extract valuable minerals from recycled electronic waste. But the reality is that only about 20% of the e waste is recycled, the rest is discarded. In any case, more precious metals than are currently in circulation will be needed to supply materials for the transition to clean energy. As a member of the Deep Sea Conservation Coalition said, you can't recycle what you don't have.
Right.
Yeah. More shipping. Melting sea ice has opened up waterways in the Arctic, enabling shipping to increase by 25% between 2013 and 2019. As more oil takers and bulk carriers traverse the region, the result has been an 85% increase in black carbon, mainly from their use of heavy fuel oil. When the black carbon, a form of air pollution that results from the incomplete combustion of fossil fuels, lands on the snow or ice, it darkens it and hastens the melting. Black carbon also causes respiratory and cardiovascular illnesses in humans. The UN's International Maritime Organization has banned the use of heavy fuel oil in the Arctic, but the ban won't go into effect until 2029.
Yeah.
So I guess that means, for the next 6 years, go
for
at
it.
it, man. Just
Yep.
go for it.
Just go for it.
Burn it all up. With the melting summer ice, cruise tourism is also increasing. 2016, the first large cruise ship traversed the Arctic and stopped at Nome, Alaska. This summer, 27 cruise ships were scheduled to dock there. More cruise ships mean more carbon emissions that blacken the ice and disrupt marine ecosystems. Thawing permafrost. Global warming is also causing the thawing of permafrost, ground that remains frozen for 2 or more consecutive years. It is found at high latitudes and high altitudes. mainly in Siberia, the Tibetan Plateau, Alaska, northern Canada, Greenland, parts of Scandinavia, and Russia. Permafrost, some of which has been frozen for tens or hundreds of thousands of years. Get your head around that. Stores carbon based remains of plants and animals that froze before they could decompose. Scientists estimate that the world's permafrost holds 1,500 billion tons of carbon, almost double the amount of carbon currently in the atmosphere. As permafrost thaws, the microbes within consume the frozen organic matter and release carbon dioxide and methane into the atmosphere. This accelerates warming, precipitating even more permafrost thaw in an irreversible cycle. Scientists project that two-thirds of the Arctic's near-surface permafrost could be gone by 2100. When the ice in permafrost melts, the ground becomes unstable and can slump, causing rock and landslides, floods, and coastal erosion. The buckling earth can damage buildings, roads, power lines, and other infrastructure. It is affecting many indigenous communities that have lived and depended on the stability of frozen permafrost for hundreds of years.
Mm-hmm.
What lies under thawing permafrost? Microbes. As the permafrost thaws, bacteria and viruses that have been hiding underground for tens of thousands of years are being uncovered. 1 gram of permafrost was found to harbor thousands of dormant microbe species. 1 gram. Some of these species could be new viruses or ancient ones for which humans lack immunity and cures, or diseases that society has eliminated, such as smallpox or the bubonic plague. In 2016, 100 people in Siberia were hospitalized and a boy died after contracting anthrax from an infected reindeer carcass that had frozen 75 years earlier and become exposed when the permafrost thawed. Anthrax spores entered the soil and water and eventually the food supply. Much older specimens have also been uncovered. Scientists have revived a 30,000-year-old virus that affects amoebas and discovered microbes more than 400,000 years old. Some of these
Amoeba.
microorganisms may already be resistant to our antibiotics.
But they're
Pollut-
amoebas, not humans, Jennifer. Not yet.
okay. Pollutants. Because the Arctic has been covered by ice and permafrost for much of human history and was largely inaccessible, it was an ideal place to dump chemicals, biohazards, and even radioactive materials. The risk these materials pose in the light of thawing permafrost are poorly understood. Radioactive waste from nuclear reactors and submarines, nuclear testing, and dumped nuclear waste can be exposed by melting ice and thawing permafrost. Chemicals and pollutants, such as DDT and PCBs, that were transported through the atmosphere and frozen in the permafrost may also resurface. Heavy metal mine waste resulting from decades of extensive mining in the Arctic is found in the permafrost as well.
We just
The increased water flow resulting from the thawing permafrost will enable pollutants and microorganisms to spread more easily, with the potential risks to ecosystem, local communities, and the food chain. The increase in cruise ships, tourism, mining, and commerce in the Arctic could expose more people to pathogens and pollutants. Is there anything positive about melting glaciers and thawing permafrost? There are many disasters that could result from the melting glaciers and thawing permafrost, but there may also be a few potential benefits. One study found that the new shipping routes opened by the melting ice in the Arctic could reduce the travel time between Europe and Asia substantially. The Arctic routes are 30 to 50% shorter than the Suez Canal and Panama Canal routes and can cut travel time by up to 14 to 20 days. Ships will thus be able to reduce their greenhouse gas emissions by 24% while saving money on fuel and ship wear and tear. New mining opportunities in previously inaccessible areas and in deep sea will make it possible to obtain the quantities of rare and precious metals needed to transition to clean energy economy. The chairman of the metals company said, "The reality is that clean energy transition is not possible without taking billions of tons of metal from the planet." The microbes and viruses that have lived in the permafrost for millennia had to develop many adaptations to withstand the harsh environment and may help develop new antibiotics. To survive, bacteria competed with each other by producing antibiotics, some of which may be entirely new. While some microbes have been found to be antibiotic resistant, others might have been able to develop new antibiotics for medical use. In the Arctic soil uncovered by thawing permafrost, scientists discovered new bacteriophages, bacteria eaters, each one of which consumes a different bacterium. Researchers found one bacterium that could survive in cold and biodegradable oil in contaminated Arctic soil. The bacterium was able to take up 60% of the soil around it. This could potentially help to clean up oil spills in the Arctic. Two other bacteria recovered from thawing permafrost were found to degrade dioxins and furans, volatile liquids, which could aid in remediating contaminated sites. One researcher is studying whether organisms in permafrost can produce enzymes that break down plastics. The melting ice and thawing permafrost have also revealed geography and ancient artifacts that are deepening archaeologists' understanding of history and culture. In the mountains of Norway, melting ice revealed remote ancient mountain pass and artifacts from the Roman Iron Age and the time of the Vikings. The pass was an important path for moving livestock between grazing sites and a passageway for travel and trade. Researchers also found numerous tools, artifacts, weapons that belonged to the Vikings. In the Jotunheim mountain range of Norway, archaeologists discovered an iron arrowhead dating back to the Norwegian Iron Age. This year, when Antarctic sea ice cover hit a record low, researchers in the Weddell Sea, a remote part of Antarctic, were searching for the wreckage of Sir Ernest Shackleton's ship Endurance. It
That was
had been
cool.
trapped,
Yeah.
and they found it. It had been trapped in the sea ice and sunk in 1915. They were able to find the ship almost 9,900 feet underwater. Jeez, that's amazing. That's almost 2 miles down,
Uh-huh.
due in part to reduced ice cover. In the thawing permafrost of the Yukon, scientists found a perfectly preserved wolf pup that lived 57,000 years ago during the Ice Age. Camel bones from 75,000 to 125,000 years ago, and teeth from a hyena like creature that lived 850,000 years to 1.4 million years ago. Because the specimens are well preserved and contain genetic material, they can help scientists understand how species responded to climate change and human impacts long ago. As the planet warms, Some countries and regions will lose out, while others will benefit. For example, Siberia will likely become a huge wheat producer, and Canada a major wine producer. Hmm. Greenland's economy currently relies on fishing, tourism, and hunting, but it will need to exploit its natural resources to support an aging population. The sand and sediment released by Greenland's melting glaciers could be worth more than 1.11 billion because the world faces a severe
Cha-ching.
shortage of the sand needed to make concrete, computers, and glass. While dredging sand and transporting it could cause environmental damage, a clear majority of Greenlanders polled want their government to explore the extraction and exportation of
Of
sand.
course they do.
As Greenland's glaciers retreat, they also leave behind silt crushed into nano sized particles by the weight of the ice. This nutrient rich mud, called glacial rock flour, gives plants more access to nutrients such as potassium, calcium, and silicon while
That was
absorbing
cool.
CO2 from the air.
Hmm.
Adding 27.5 tons of glacial rock flour per hectare increases barley yields in Denmark by 30%. Applying 1.1 tons of it to fields absorbs between 250 and 300 kilograms of CO2. The more than 1 billion tons of glacial rock flour deposited yearly on Greenland could enable farmers to sell carbon credits because of the CO2 absorbed and boost the country's economy. The changes raise complex questions. Ultimately, these relatively small potential benefits cannot outweigh the enormous impacts climate change will have on local communities and the planet. Do I believe that these kind of changes, mining and shipping opportunities, are translating into something positive for the broader society of the planet? Absolutely not, said Schaefer. They will further enrich an already incredibly rich, tiny minority of capitalists. So the rich get richer.
Yes.
8 countries claim territory in the Arctic: Canada, Denmark, because Greenland was its former colony, Finland, Iceland, Norway, Russia, Sweden, and the United States, some with overlapping geological claims. As the region warms and new opportunities for exploration arise, near Arctic countries such as China, Japan, South Korea, Britain, and EU members are becoming more focused on the region as well. Intelligence analyst Rebecca Koffler has warned the Arctic is going to be a future battlefield for economic
Hmm.
dominance
It
and possession
sure
of
is.
natural resources. It is a geological reality that, as ice melts and permafrost thaws, many surfaces will get exposed. Schaefer believes the best thing to do is to tighten laws so that outsiders or wealthy private companies cannot simply exploit resources without any responsibility to the planet
Okay.
or the people who own the land. The
Okay.
question of who will benefit from climate change impacts and from the melting and thawing regions in particular is complicated. Schaefer believes these issues are moving away from climate science and into law and ethics, and that perhaps the best framework for resolving them is to prioritize climate justice. He said, the voices and votes of the people who live there and own the land need to be at the center of everything. And that's that.
That one I thought was really good. Of course, they splash in their bit of hopium, everybody does. But I liked some of the interesting positives, the fertilizer, using the
I know.
breakdown in fertilizer. But of
I
course,
know.
that will be exploited. I
Of
just,
course it will.
of course it will.
Of course it
I
will.
hate to be like that too, but that article, it did make me feel it made me feel sad, Jennifer, because the
Yeah.
totality of it all. Well, thank you for
Yes.
reading that. Did you want to talk about the Lena River a little bit, where they're getting
Oh,
all of
sure.
the, change gears a little bit before we
Yeah,
bring her
sure.
home with the next couple of articles?
Sure, absolutely. So let's dive
Yeah.
into the Lena River. The Lena
Okay.
River, it dumps out, it's in Siberia, it dumps out in the Laptev Sea. You guys have probably seen the big, big delta and the big deposits in the delta that kind of hump out a little bit. And it is an area that is very high in methane and decomposing permafrost. So there you go. The Lena River is one of Russia's great northern rivers, draining an area of 899,641 square miles. They should have just said 900,000 square miles. I'm going to say 900,000 square miles,
Okay.
and encompassing a region rich in wildlife and natural resources, including cats getting off. There we go, including one of the world's largest deposits of gold. Ooh, wow. This is also one of the most inhospitable regions on the planet, with extremes of temperature and vast stretches of northern forest. 84% forest. Few people live in the region, and there is only one city in the entire Lena Basin, Yakutsk, the administrative seat of the former Yakut Autonomous Socialist Republic, and now the capital of semi independent Yakutia, renamed the Republic of Sakha in 1991. The river, 2,800 miles long,
Unreal.
flows mostly through Sakha, but its origins are in the Irkutsk district immediately west of Lake Baikal. Its tributaries have their headwaters in the autonomous Republic of Buryatia and the district of Chita, Amur, and Khabarovsk. The river starts in Baikal Range, only a short distance from the lake itself, though the lake's waters flow into the Angara River and joined by its first major tributaries, the Vitim and the Olkama, whose headwaters originate in the Yablonov and other parallel mountain ranges east of Lake Baikal, which are also the source of the headwaters of the Amur River.
Oh.
The river then turns north in a large arc, following the contours of the Aden Plateau to the south. Okay. And I was just checking how long this was.
Oh, we don't have to
From
go all
the
the way down.
it's a big long geography lesson, and I don't think we need to go through
No,
the entire thing, but I kind
but
of
it's
want to look at that
amazing.
picture. Do you see that picture with the cliffs of the
Yeah.
Lena River?
Isn't it
So
gorgeous?
those cliffs are caused by intense flooding, right? So whenever you see that, it's really caused by intense flooding, and that's like giant erosion, and those things can form very, very quickly from abrupt climate change events, like at the end of the last ice age, cause many cliffs like that to come
Wow.
into being, right? So that's
Wow.
a lot of water going through there. That's
Lot.
kind of interesting.
All right. Well, thank you. And let's move on. I
All
already
right.
went through him. Okay. So this was the pièce de résistance. It's going to go over a lot of what we've already discussed, but this is the CNN article that started the whole thing going all over the media again. And I'll just do a quick overview on this one because I want to really go down to when they talk to him, our guy. So it talks about permafrost, where it covers Alaska, Canada, Russia, the northern hemisphere, Arctic tundra, boreal forest. And this is the guy to understand the risk posed by these viruses. And like I said, he wasn't always the virus hunter. Jean-Michel Claverie, an emeritus professor of medicine and genomics at the Aix-Marseille University School of Medicine in Marseille, France. He's tested Earth samples taken from the Siberian permafrost to see whether any viral particles combined therein are still infectious. He's in search of what he calls, he describes them as the zombie viruses, and he says he's found some. So when I made the video for you, I found that talk that he gave, and then I just edited it, added graphics and all. And if you want to go back and look at it again, it will, of course, the link for the whole thing will be in the show notes. So the virus hunter, Claverie, studies a particular type of virus which he discovered in 2003. These are the giant viruses, and oh my gosh, this has been so fascinating to go over and learn. They are much bigger than the typical variety and visible under a regular light microscope rather than a more powerful electron microscope. It makes them a good model for this kind of lab work. His efforts to detect viruses frozen in permafrost were partly inspired by that team of Russian scientists who in 2012 revived a wildflower from a 30,000-year-old seed, and that was using David Gilshevsky's lab. In 2014, he managed to revive a virus that he did, and he made it infectious for the first time in 30,000 years by inserting it into cultured cells. For safety, he'd chosen to study a virus that could only target single-cell amoebas, not animals or humans. So that was something he made very clear. And that was even when he was clear about that in 2018 and 19 when he gave the talk that I used. He repeated the feat in 2015, isolating a different virus type that also targeted amoebas. And in his latest research, published February 18th in the journal Viruses, Claverie and his team isolated several strains of ancient virus from multiple samples of the permafrost taken from seven different places across Siberia, and showed that they could each infect the cultured amoeba cells. So that's pretty wild stuff. It's very wild. He says the latest strains represent the 5 new families of viruses, which he had found. He had found, the 2. The oldest was 48,500 years old, based on radiocarbon dating of the soil, and came from a sample of earth taken from an underground lake 16 meters, which is 52 feet below the surface. The youngest samples found in the stomach contents and the coat of the woolly mammoth's remains were 27,000 years old, Jen. Wow. Yeah. That amoeba infecting viruses are still infectious after so long is indicative of a potentially bigger problem. Claverie said he fears people regard his research as a scientific curiosity, and he doesn't perceive the prospect of ancient viruses coming back to life as a serious public health threat. We view these amoeba infecting viruses as surrogates for all other possible viruses that might be in the permafrost, he told CNN. We see the traces of many, many other viruses, he added. So we know they are there. We don't know for sure that they are still alive. But our reasoning is that if amoeba viruses are still alive, there is no reason why the other viruses will not still be alive and capable of infecting their own hosts. So the precedent for human infection. Traces of these viruses and bacteria can affect humans and have been found preserved in the permafrost. A lung sample from that woman's body in 1997 from the permafrost in the village of the Seward Peninsula of Alaska contained genomic material from the influenza strain, and we talked about this earlier, in the 1918 pandemic. In 2012, scientists confirmed that the 300-year-old mummified remains of a woman buried in Siberia contain the genetic signatures of the virus that causes smallpox. An outbreak in Siberia that affected the humans and the reindeer, that was in 2016, which we started with. That also has to do with the warm summers, and it allowed the Bacillus anthracis to resurface on the burial grounds or where the animals died. Brigitte Evangard, professor emerita at Umeå University's Department of Clinical Microbiology in Sweden, said there should be better surveillance of the risk posed by potential pathogens in thawing permafrost, but warned against an alarmist approach. You must remember, our immune defense has been developed in close contact with microbiological surroundings, said Evangard, who is part of the CLINF Nordic Center of Excellence, a group that investigates the effects of climate change on the prevalence of infectious diseases in humans and animals in northern regions. If there is a virus hidden in the permafrost that we have not been in contact with for thousands of years, it might be that our immune defense is not sufficient, she said. It is correct to have respect for the situation and be proactive, not just reactive. And the way to fight fear is to have knowledge, which is what we're giving you guys tonight, I hope. So, what about the chances of a viral spillover? Of course, in the real world, scientists don't know how long these viruses could remain infectious once exposed to present-day conditions, or how likely the virus would be to encounter a suitable host. Not all viruses are pathogens that could cause disease, like probably hardly any of them, really. Some are benign or even beneficial to the hosts. And while it is home to 3.6 million people, the Arctic is still a sparsely populated place, making the risk of human exposure to the ancient viruses very low. But still, the risk is bound to increase in the context of global warming, Clevery said, in which permafrost thawing will keep accelerating and more people will populate the Arctic in wake of industrial ventures. And Clevery isn't alone in warning that the region could become a fertile ground for spillover event when a virus jumps into a no host and starts to spread. Last year, a team of scientists published research on samples of soil and lake sediment taken from Lake Hazen, a freshwater lake in Canada located within that Arctic Circle. They sequenced the genetic material in the sediment to identify viral signatures and the genomes of potential hosts, plants, and animals in the area. Using a computer model analysis, they suggested the risk of viruses spilling over to new hosts was higher at locations close to where large amounts of glacial meltwater floated to the lake, a scenario that becomes more likely as climate warms. That's pretty wild. So, unknown consequences. Identifying viruses and other hazards contained in the warming permafrost is the first step in understanding what risk they pose to the Arctic. Miner at NASA's Jet Propulsion Laboratory said it. Isn't that where Peter Kalmus is also? I believe he is.
I guess so. I think so, yeah.
Other challenges include quantifying where, when, and how fast and how deep the permafrost will thaw. Thawing can be a gradual process of as little as centimeters per decade, but also happens more rapidly, such as in the case of massive land slumps that can suddenly expose deep and ancient layers of permafrost. The process also releases methane and carbon dioxide into the atmosphere, an overlooked and underestimated driver of climate change. So, Miner cataloged an array of potential hazards currently frozen in Arctic permafrost in a 2021 paper published in the scientific Nature journal Climate Change. Those possible dangers included buried waste, like was discussed before, from mining of heavy metals and chemicals such as the pesticide DDT, which was banned in the early 2000s. Radioactive material has been dumped in the Arctic by Russia and the United States since the advent of nuclear testing, and that makes me so angry. Just the ignorance of it all. How could that happen? Abrupt thaw rapidly exposes old permafrost horizons, releasing compounds and microorganisms sequestered in deepest layers, Miner and other researchers noted in the 2021 paper. In the research paper, she labeled the direct infection of humans with ancient pathogens released from permafrost as currently improbable. However, she said she is worried about what she termed as the Malthusian microorganisms, named after the biblical figure with the longest lifespan. These are organisms that could bring the dynamics of ancient and extinct ecosystems into the present day Arctic with unknown consequences. The reemergence of ancient microorganisms has the potential to change soil composition and vegetative growth, possibly further accelerating the effects of climate change, Miner said. So we're really unclear as to how these microbes are going to interact with the modern environment, she said. It's not really an experiment that I think any of us want to run. The best course of action, she said, is to try to halt the thaw and the wider climate crisis and keep these hazards entombed in the permafrost for good, which, Jennifer, we're not seeing that happening. But
the permafrost is not going to be perma much longer.
I'm telling you, it's not. But I thought that was also, so that's the CNN article that has spurred the whole mess that's going on everywhere, all over social media. And I thought, okay, let's do the history. And this is the article. I'm just going to show you this. This is one of the articles that I read, and this is the other one. This is really good. The update on eukaryotic viruses revived from the ancient permafrost. And of course, I'm not going to read this, but they really do show you how they've done this. They name the Pandora virus, the Cedra virus, the megavirus, the Pac-Man virus, and the Pithavirus, and those are the larger virus strains. Those are the giant viruses that were not understood until very recently, which Claverie, he's the one that really has exposed them with the other researchers that he had been working with. So this whole, if you want, this will be in the, they both will, they'll be in the show notes. And we're going to go to this last article because it's really, really, really critical to how we go forward. How are we going to go forward? And I just wanted to say hi to you in the chat. And I know we have a few questions. I think we'll just wait until after, because the last one is something that we are all thinking about and we're all hurting over it.
All right. Well, let's go ahead and take it away. This is from Yale360.edu. How tensions with Russia are jeopardizing key Arctic research. With the Ukraine war, international collaborations with Russia and on Arctic research and oversight have been strained or broken off. This loss of critical cooperation is compromising efforts to confront mounting environmental risks in the Arctic, from shrinking sea ice to pollution. Biologist Eric Reger and his colleagues in the U.S. Fish and Wildlife Service began studying polar bears from the American side of the Chukchi Sea, which stretches from Alaska to Russia, in 2008. But as the region warmed and the increasingly thin sea ice off Alaskan coast made helicopter landings unsafe, he knew he would need to find another base from which to survey the health and size of the population. Russia's remote Wrangel Island made an ideal alternative. Also, the last stand of the woolly mammoths, right? Wrangel Island, 4,000 years ago. A large proportion of the Chukchi Sea polar bears take refuge here during the summer, and the Russian Federation had in 2000 signed an agreement with the US to protect this population. Collaborating in the field, Russian and American scientists were eventually able to confirm in 2016 that the population of 3,000 animals appeared to be faring well, despite the rapidly receding sea ice and indigenous subsistence hunting. After a 2 year hiatus became because of COVID-19, Reger, now with the University of Washington, was eager to return to his research on Wrangel. But when Russia invaded Ukraine last February, his plans abruptly changed. So did those of virtually every government, university, institute, nonprofit scientist working with Russian colleagues. Suddenly, nearly every international collaborative effort with Russia in the Arctic, from polar bear to whale studies to research on commercial fishing, permafrost thaw, sea ice retreat, peatland ecology, and wildfires, was on hold. The cessation of scientific collaboration comes at a precarious moment for the Arctic. So much of what we need to know about these impacts is being lost, Reger says. It's hard to see how we are going to be able to resume the science without the government and non government funding for us and the Russians, and without us being there to work with their scientists. The cessation of scientific collaboration comes at a precarious moment for the Arctic. Environmental risks associated with sea loss, pollution, shipping are increasing. Russia and other Arctic states are proposing new boundary lines along the continental shelf that would expand their claims over the Arctic Ocean seabed, and peatlands have been continuing to burn year after year of record setting wildfires in northern Russia, adding substantially to the nation's greenhouse gas emissions. Russia is the world's fourth largest emitter of greenhouse gases.
Wow.
In addition, China is ramping up its economic interests in the Arctic. The Arctic has long been a model for optimism and international cooperation, said Evan T. Bloom, a senior fellow at Wilson Center in Washington, D.C., and the former U.S. diplomat engaged for nearly 3 decades on Arctic governance. The disruptions of cooperation is necessary because of the Ukraine crisis, but there can be no progress on pan-Arctic issues without Russian participation. Scientists from around the globe have collaborated in the Arctic at least since the Cold War. 3 years after the Cuban Missile Crisis, representatives from the Soviet Union attended the first of many circumpolar meetings on the study of polar bears, which were in serious decline from overhunting. The Soviet Union was a signatory to the International Convention for the Prevention of Pollution from Ships, which went into effect in 1973, and the Five Nation Agreement on the Conservation of Polar Bears, which went into force 3 years later. The Russians have also been intimately involved with the International Maritime Organization and the World Meteorological Organization, which provides the framework for international cooperation on weather, climate, and water cycles both in the Arctic and around the globe. And they have been a key player in the Arctic Council, the leading intergovernmental forum promoting cooperation among the 8 Arctic states. The Council meets regularly, with nations holding 2-year rotating chairmanships to work on the issues related to sustainable development and environmental protection. Now, much of this international collaboration is on pause, partly because the other 7 Arctic Council states have suspended communication with Russia. Other projects have halted completely as government scientists and non governmental organizations in Russia have fled the country, been silenced by Russian authorities, or denied the
Oh,
international funds, expertise, infrastructure needed to keep their joint work going.
so sad.
Yeah. Russia has half the Arctic's landmass and jurisdiction over most of the Arctic. An October 2022 report commissioned by the Finnish Prime Minister's office summed up the impact of Russia's aggression on international Arctic cooperation by acknowledging that, while conditions may change, one thing is certain: there will be no return to the pre war reality. The loss of Russia, both as a collaborator and as an active member of the Arctic Council, is profound, notes Bloom,
Profound.
because the country has half of the Arctic's landmass, jurisdiction over most of the Arctic Ocean, is home to nearly half of the Arctic's population, and oversees most of the region's economic development. Prior to the war in Ukraine, scientific and diplomatic progress was being made on many emerging environmental issues, including the agreement to prevent unregulated high sea fisheries in the central Arctic Ocean. Most of this region is covered by ice year round, preventing the possibility of a commercial fishery. But as the ice retreats, fishing countries could eventually move and wipe out fishery stocks, as happened with walleye pollock, an unregulated area of the Bering Sea in the 1980s. The key elements of the Central Arctic Ocean Agreement, which takes a scientific based approach to fisheries and management before permitting commercial fishing, is in peril without Russian scientists verifying data that would form the basis for launching future fisheries. Some Russians did show up at an international meeting on the Central Arctic Ocean fisheries that was held in South Korea in November of 2022, says Bloom, who was invited to speak virtually on the significance of fisheries agreement at the meeting. Quote, but they were low level and without the authority to make decisions about future scientific participation, he says. It's hard to see things moving forward so long as there is war in Ukraine. The war in Ukraine has also put a halt to many climate based collaborations with Russia. Russia has more peatlands than any other country. Carbon rich, many of these peatlands have been badly degraded by mining, agriculture, forestry practices, and oil and gas development. And climate change has made them vulnerable to wildfires. In 2010, Russia had 30,000 fires in more than 20
Wow.
regions.
I remember that.
Wildfires and peatland degradation currently account for 5% of the country's greenhouse gas emissions. Following the catastrophic 2010 fire season, the German government offered money and expertise to help restore the hydrological regimes that keep Russia's peaty bogs, fens, and marshes wet and their carbon sequestered. But on the day that Russia invaded Ukraine, German institutes, including the Sukhov Foundation, withdrew their support. Just weeks afterward, a Russian bomb in Ukraine likely triggered a wildfire in the forest around Chernobyl
Scary.
nuclear site, a focus of another re-wetting project. Tatiana Minyeva, a Wetlands International scientist who previously worked as a research and scientific consultant for the Russian government, says much progress had been made in Russia peatland restoration before war broke out. But With little chance of collaborations resuming, she hopes the remaining funds from international donors will go to other peatland sites in Central and Eastern
Hope
Europe.
so.
Most of Russia's peatlands are frozen in the permafrost, which is thawing faster than permafrost in other Arctic nations. Much of the data on this thawing comes from Germany based Alfred Wegener Institute for Polar and Marine Research, which in February of 2022 pulled its support from Samolov Island Research Station in Siberia's Lena Delta. The station can host up to 20 scientists at a time and has been collecting reliable data on permafrost since 1998.
Oh, I can't stand it.
Following Russia's invasion of Georgia in 2008 and Crimea in 2014, the Arctic Council found ways of navigating through the crisis without pausing communications with Russia. And nonprofit organizations with offices in or close ties to Russia helped keep back channels open when the Arctic Council wasn't willing or able. Following Russia's annexation of Crimea, for example, the Pew Charitable Trust persuaded Russia and the US, Canada, Iceland, and other countries to meet in Shanghai in 2015 to discuss the proposed Central Arctic Fisheries Accord. There is ample opportunity for Arctic governance to get much worse, says a former
You
diplomat.
think?
Oh, wow.
God.
But today's situation is quite different, says Clive Tessar, former head of communications and external relations for the World Wildlife Fund Global Arctic Program. Many of those back channels are now closed or silenced. And now that the 7 other Arctic Council states are no longer communicating with Russia, it's unclear how international collaborations on a non governmental level can even move forward. The World Wildlife Fund has worked in Russia since the 1980s, when it financed the establishment of the Great Arctic Reserve, the largest nature reserve in Eurasia. Since then, it has been involved in more than 1,000 field projects, many of which led to the protection of more than 200,000 square miles of unique territories, most of them Arctic and subarctic regions. It's going to be very difficult to get things back on track as this war continues, said Tessar. Evan Bloom, who helped establish the Arctic Council and served as the lead U.S. negotiator in establishing the world's largest marine protected area in Antarctica's Ross Sea, has been through many international crises, notes that the future of the Arctic research is not all gloom and doom. Multilateral research on the Arctic will continue in Canada, Alaska, Greenland, and in Norway's Spitsbergen Island. But the Arctic Council is a forum regulated by consensus, Bloom says, and nothing goes forward there unless all parties agree.
Mm.
If the situation in Ukraine gets worse, there is ample opportunity for Arctic governance to get much worse. With Arctic Council communications with Russia suspended indefinitely, the 7 other Arctic Council states could continue working on plans that don't involve Russian territory, Bloom says, but that might anger and alienate Russia, preventing its future return. Even if the Arctic Council did find a way to reconcile with Russia or forge a different path forward, it's hard to imagine the research community returning to a pre-war normal because so many Russia's best scientists have fled the country or are looking for ways to emigrate. Some, like Olga Spock, a Ukrainian marine biologist formerly working with the Russian Academy of Sciences, Svertov Institute for Ecology and Evolution, gave up her research to volunteer on the front lines to defend her hometown last spring. My life has changed drastically on February 24th, she said in a meeting of the Council for the Advancement of Science Writing last October. My priority is not science, not Arctic, not whales, but people. So there you go.
Oh, there you go. Well, it's very important for that. The scientists, the Russian scientists, and with the American scientists, with the world scientists, it is a huge loss for now. And who knows when it's going to come back. And especially, I don't think that Clavier, uh, I don't think he can get any kind of samples. They won't be able to do any more research together. They're not going to be able to go to each other's research facilities. And the scientists, it's a huge loss.
Mm-hmm.
And we're not talking about the war tonight. We're talking about the loss, the science war. Basically, it's a science
Yeah,
war.
that's right. That's right.
Now, how you guys doing out there? This was a long show. I'll probably take a few pieces out of it and make shorts, but I see a lot of. Do we have questions? We had one. Gary Hoover had a question. What would be the most likely way these viruses would spread to humans in large numbers? Is this more or less likely than use of weapons of mass destruction, nuclear, chemical, or biological? I don't think that these are being scientifically examined in any kind of nefarious way at all. And we won't know anymore. And I want to say Russia wouldn't do that. I mean, these are, but it was a biolab. So I mean, that sounds like, does that sound like hopium? I don't know. The scientists were really dedicated to finding out ways to mitigate viruses from decimating populations. So we don't know what's going to happen.
Mm-hmm.
All right,
Yeah.
let's see. Anybody else? Channel Warhorse. Thank you, Sandy and Jen. I have no idea what's going to happen this year, but something's going to happen. Well, something happens every year. How the rest of you guys doing out there? Thank you for coming. Jennifer, would you like to neatly tie up the way only you can?
Well, I mean, the permafrost is melting or thawing quickly. It's becoming permamush. I mean, it's not going to get frozen again, especially if everything is warming as quickly as it is. So these viruses are going to continue to come out of the land, and who knows if they make the jump to human beings. I mean, they did make the jump to human beings. That anthrax, that 75-year-old reindeer, one indigenous boy died, and I know that doesn't sound like much, but it did make the jump. So it is possible that these viruses could become, the zombie apocalypse. It's completely possible.
I don't want to think about it being possible, but of course, we're here thinking about it being possible. But they haven't studied, they can't study anything about humans. And now it's just, shut down, done. Unless, Canada, Norway, the other countries that are left are going to study the what they find, but without the Russian Arctic. It's just, whatever. Well, thank you everyone for coming to this show. We hope you learned. I hope you liked the video. I hope you liked our virus hunter. It's really not what I call the zombie apocalypse yet. I don't call
No, it is not. It's a long way from that.
Yeah.
So, as Gary Hoover says, almost every show, something about living deeply and caring deeply and letting go gently. I don't know, but I kind of feel that sort of sums it up. Be grateful for what you have. Be grateful for the world the way it is, because it's probably going to get worse.
Oh, that's a great way to end. But yeah, I mean, things don't look so fabulous right now, do they? Also, I just want to tell everybody we're going to have a show with Nicholas Humphrey, the meteorologist, that our meteorologist that's working on a PhD, and we are going to talk about the potential for El Nino, the sort of a postmortem on the La Nina, and what have we looked at and what are we looking at? So save your questions. That's going to be towards the end of the month, right, Jen? And there you have it. I'm going to do a show on Tuesday night, 2 shows a week for now, until I think a different way. So from this crone to all you crones out there, have a great
Crones
night.
unite!
Crones
unite!
Crones unite! Yay!
Yes,
Crones
yes.
unite! I love
Crone
you, Jennifer.
power.
Crones unite.